Welcome to Totally Integrated Instrumentation. If you like what you see, please hit the subscribe button. If you're watching from LinkedIn, hit the YouTube, watch within YouTube, and click the notification to receive instant updates. Don't forget to like the videos. Your feedback is very much appreciated. And from here, you can visit the site, see the rest of the videos, and leave any comments or any suggestions for future blogs. Thank you.
Hello, my name is Martin Ruck. I'm one of the product managers for Siemens, and today I'd like to talk to you about Siemens SIWAREX weighing technology range. This is a quick overview of the complete weighing portfolio from Siemens. It's not a new portfolio for Siemens. The weighing technology has been part of the portfolio since the early 1970s. But as it stands today, there's a range of SIWAREX weighing electronics, which is what we're going to talk about today, which are electronics types which are directly integrated with the PLC or with the CPU. On here, there's a range of load cells and mounting structures and junction boxes which obviously integrate with the weighing applications to these weighing electronics. Obviously we understand that not every application is integrated to a PLC. So there's a range of electronics that also are for standalone applications, and the associated software that works with these electronics. On the hardware side, from the dynamic belt weighing side of it, or conveyor belt weighing side of things, there's a range of belt scales that integrate into existing conveyor belts. So there's a range of these mounting structures or conveyor belt scales to suit the appropriate application, which also comes with the speed sensors and associated components around those applications as well. There's also an option for weigh feeders, so if you wanted a small weighing conveyor, we also have the option to supply the complete weigh belt or weigh feeder for you for certain applications as well. Impact flow meters or solid flow meters, so these are structures, mechanical structures really, which are for if I have a stream of dry solids material flowing through some pipework, so for example cement or grain flowing through this pipe, there's an impact plate here. I hit the impact plate with that product, deflect the plate proportional to the flow, and I can output a flow rate or a totalized flow of that stream of dry solids material proportional to there. So that's an overview of the complete weighing portfolio from Siemens, but today we're going to dig in a little bit deeper and give you an understanding of the SIWAREX portfolio, so the weighing electronics and load cell structures. So if we look at weighing, feeding and force measurement applications out in the field, there's a whole variety of different applications that require measurement and solutions for these. The good news is that 95% of these applications use strain gauge load cells, which directly integrate into the SIWAREX modules. You will find that some applications use digital load cells. Now they can be integrated into certain SIWAREX modules, but most often those are integrated direct to the PLC anyway. When we look at, if you're familiar with the Siemens PLC family or the CPU types here, the SIWAREX family is essentially modeled directly on this. So for each CPU type that you're looking at, there is a SIWAREX weighing module that would integrate directly with it. So for example, if I have an S7 1200 PLC, there would be a SIWAREX WP. WP stands for weighing processor. 231 would be the example here, that would integrate directly with that CPU type. If I had maybe an ET200SP, there would be another module, a WP321 in this case, that would integrate directly with that one there. So each one of those is sort of tailored to match which controller type you're using in the field. It is possible, like I say, to have these as standalone, and they also take that to another level where they would actually package up a HMI with a controller, with a weighing processor, so that all you have to do is wire your load cells in, apply power, and you have a pre-configured solution ready to go, rather than integrating the weighing modules into your existing projects. So looking at the most current portfolio that's out there from the controller, from the CPU side, if we have an S7-1200, a 1500 or an ET200 SP, there are different weighing processors that work with each one of these modules. So I'll stay with the S7-1200 for now. So if we looked at an entry level weighing application, a silo or a hopper scale, platform scale, we would be using a WP231 module, which would integrate directly into a 1200 and use that unit. If we then said, okay, I need to use a belt scale application, we would change that module for a WP241, which would then bring in things like maybe, as well as the load cell input wire into the device, we would now be bringing in the speed sensor wire into that application as well. If we were stepping up to maybe a little bit more complex weighing application where we're doing dosing or batching, the 251 would give us the option now for having that dosing and batching functionality direct within this weighing processor, rather than doing other work in the engineering work. And that philosophy follows with the other CPU types. So why would I want to integrate my weighing electronics direct to the PLC anyway? If I look at maybe a structure, a typical application, so normally we have a mechanical structure which would be using, say, a weighing structure which is using strain gauge load cells, or a load bearing structure using the same load cells. This load cell could be a compression or a tension load cell. So for more load applied to a compression load cell, the more deflection I get, the more signal I get proportional to the load applied to it into a load cell amplifier, where I'm going to condition that signal and scale the unit, output the signal to a control system, so to the CPU, or out to a visual, to a panel meter in the field for a visual output. So if I look at that application and said, okay, right, well, what am I doing here with analog to digital conversion? Each one of those areas where I'm converting that signal is an area for risk and for contamination, where potentially I could have a problem and cause a problem with my scaling. If I look at maybe configuration of this application, I need an automation specialist to be able to program the PLC. I need a load cell or a weighing specialist for my amplifier potentially, and I need a guy in the field as well who can configure this. Though, to be honest, most of the time the issues come here, where I need to have the specialist for automation on site the same day as I do for the weigh-in specialist. Otherwise I end up with things like post-it notes left lying around for scaling devices to match, and hopefully things tally up on the day. If I look at diagnostics on here, I need an automation specialist if I have a fault here, I need a weigh-in specialist if I have a fault here, and I need a guy out in the field to look at the diagnostics of the hardware as well. So what is the difference to the integrated solution? Well, if we look at that now, if I have the weighing module directly integrated into the PLC, I now just have one analog to digital conversion going on, one area of element of error that could creep in here. I'm showing configuration, and I look at that. I'm showing it in the PLC, but potentially this is actually just directly from the HMI. You'll see that there are ready-to-use packages for projects here, which basically bring in all of the calibration screens and quick start wizards here to commission an application directly from the HMI. So we can simplify the programming of each one of these different applications from here. When I come to diagnostics, I have that direct onto the HMI. So whether it be a fault with the CPU, a fault with the load cell, a fault with the field wiring, or it could just be a calibration issue, I can see all of that very simply on the diagnostic element of the HMI. When it comes to the load cells, there's a whole range of load cells here for single point load cells on here, different types of load cell to suit different applications. Most of the time this is based around the mechanical structure of the device here, but also we need to consider things like the environmental conditions. So if I'm in a food and bev factory and I have a need for a wash down duty load cell, I need to make sure that I've got a hermetically sealed load cell that's insensitive to water and ingress and things like that. So those are all within the portfolio. If I said I've got a weights and measures application, I know that I can pick a load cell that is basically weights and measures approval to suit those as well. So all of those are within the portfolio, but it's also equally suitable to retrofit existing load cells into the SIWAREX electronics on here. You'll see a range of mounting structures which are really based around protecting load cells for the mechanical environment that they're put into. Now that's, if I'm an OEM, I can manufacture my machine around the load cell structure and protect it that way. But if I'm retrofitting, maybe these mounting structures would be a better solution. So these give us options like, for example, if I had a very light duty load cell and someone stood on the load cell, we would damage the cell. So what the mounting structure would do would provide mechanical overload for that cell, so that basically protected that cell from being distorted beyond its safe working limit. That works not only in overload protection but maybe lift off protection. So if a cell was pulled in the opposite direction and damaged that way, that's what the lift off protection is doing. You'll also see things on there like torsional protection, as you can see on the bottom right here, and that's really maybe say if I've got an agitator twisting a cell, we're protecting that cell not only from the mechanical damage, but maybe from accuracy errors that can creep in as well on there from that twisted action applying a force to the cell. There's a new digital junction box that's available as well in the portfolio, and that really gives a deeper level of diagnostic to individual cells as well. So there's another option there. So obviously there's a load cell to suit the application type that you required, retrofittable as well. But if we looked at an overview of an application, we have these load cells wired directly into the SIWAREX weighing processor. That processor is integrated directly through the backplane into the CPU type, and then we can connect a HMI to that. With a ready to use project, we can see very quickly what the load is on that cell, and we can also go and get diagnostic and calibration directly from that screen. There's the option to use the something called SIWATOOL software, which, to be honest, this is more applicable in applications where we're using this as a standalone, but it means we can back up parameters here, or maybe where this would be useful in an integrated one is if I was a machine builder and I wanted to save different configurations that I could download to different for different applications on there. I could have those pre-configured ready to download for different application types. When I'm integrating the hardware into projects on here, this is quite simple. You'll see in the hardware catalogue for the unit, you'll see as under technology modules, you'll see the weighing modules come in here, and as you'd expect into your portal, this is just simply drag and drop it into your project to integrate that hardware. You heard me mention that there's ready to use sample projects. These are free of charge download from the Siemens Industry Support website, and the way this works is you identify the weighing processor type that you're using, in this case the 231, WP231, and then you'll find a project here that matches the CPU type that you're working with. Download that project, and then you integrate that into your existing project. So you can see we've pulled in the existing project, which has brought in the function blocks here for the weighing processor, and also the screens here for our HMI, which include all of the calibration and diagnostic screens in there. So you can see the engineering time is dramatically reduced for bringing these in. This is an example of the overview screen on one of the weighing processors. As you can see, I haven't got this set up at the moment, so I've got zeros everywhere, but potentially that would be saying so many kilograms. I can zero this application. These buttons are pre-configured here: tear it, cancel tear, preset tear, and then I also have some alarms here to basically show that the conveyor is empty, or that the device is empty, it's in standstill, or maybe I've got a high alarm limit for, say, a crane, or I'm running empty low level on an application here on a vessel, or indeed an error. So if I have an error, I can go and see the diagnostics, or if I'm commissioning, I can use the quick start wizard to program the device from scratch. So I mentioned that these could be used, certain ones of these weighing processors can be used standalone mode as well. So you can see here a 231 with a range of digital inputs and outputs and analogs. So you can imagine we could just connect load cells directly to this weighing processor and configure it using the SIWAREX software. And then I have basically a black box in the back of my panel which could be controlling my application without any other input to it. Might be more interesting to actually have a visual output on it, so I could just connect a HMI to that, which would give me all of those screens and the diagnostic functionality that I was just talking about, or I could take a signal out to a PC as well if I wanted to, so as a complete standalone without a CPU. If you're new to weighing and maybe the mechanical structure is new for you, so you know in the FIO1 or the weighing catalogue from Siemens, you'll find that there's some examples of configuration of some of these applications. So in this case we've got it's taken straight from the catalogue, is a container weighing application. So in this case we've got 4 mounting feet holding this vessel, and the information that we need to gather to do the application is what is the silo dead load, so what is the mechanical mass that's sitting on these load cells. In this case we've calculated that at 1.2 tons. Then we also need to know what is the live load of the material that's going to go into that vessel, the maximum capacity, in this case 1.8, which is give us a total load that's sitting on all 4 of those load cells of 3 tons. We divide that by the 4 load cells, so we get a capacity or loading on each cell. We add a safety margin to this depending on the application type we're doing, and we get 0.9 of a ton in this case, so sitting on a cell now or potentially on a cell. So the way we specify a load cell then is to pick really the next highest rated load cell from the standard catalogue. So in this case we would go up to a 1 ton load cell. The catalogue then goes on, or it describes really then some sample part numbers that would be applicable for that particular application. So you can see we have a 1 ton load cell here, there's the part number, and we'd need 4 of them. We potentially, if we want to use the mounting structure that goes with that, for that 1 ton cell, there's the sample part number and the type, and it goes to the detail of maybe things like the grounding cable, so maybe the weak element of a load cell or the potential for damage would be if someone say welded on this vessel. The current flowing through a sensitive load cell needs to be protected, so we put these grounding straps really either side of this across the cell to basically make a protect the load cell, so from these undesirable currents on there. So it also gives you those sort of part number level as well. So hopefully you can see then from an overview of one of these applications then, we can reduce the commissioning time on some of these applications. We could connect the HMI to mobile devices, so we can do these remotely and make this very easily accessible throughout the plant. The integration on here really has reduced that A to D conversion and improved our accuracy, and the commissioning time with the wizards on here is obviously a lot faster. And we have the diagnostics from various different levels here, from the load cells, the junction box, the CPU. We're getting that level of diagnostics back to the HMI without having to go and really put a lot of effort in wandering around the plant. So as I mentioned then, we have these sample projects which bring the function blocks and the faceplates directly into the project to reduce engineering time, which bring quick start wizards and diagnostic information. That's also available for PCS7 as well, so which is Siemens DCS, so that option's available. And we also have the option for the standalone applications, or if we want to back up remotely, the SIWAREX software, which gives us that connectivity. Available in the catalogue as a useful guide on here really, which gives you what type of application type, an example weighing processor and what PLC that is suitable connectivity to, so that's in the catalogue. But I'd also really recommend if you within the website or in the catalogue, there's www.siemens.com/weigh-in. You'll find this, basically a questionnaire for SIWAREX weigh-in applications. If you fill in one of those and send it in to sales@GB&I, those guys would be more than happy to help you, or Steve Davis and myself, Martin Ruck, would be also very happy to help you with a weigh-in application if you need some assistance. Just so you're aware of it, there's also a hotline for more in-depth technical support in addition to the UK number. This one routes directly to Manchester. There's one into Manchester in the UK, but there's also support available direct at the factory through this hotline number as well. So, like I say, if you have any weigh-in applications on there, please give us a shout. We'd be more than happy to help you with them. Other than that, thank you for your time, and this concludes the overview of SIWAREX weigh-in technology from Siemens. Thank you.